Alright, we are in the last module, Module 6 for Math 55, so you're getting close to the end. Square roots are the opposite of squaring. Note, opposites undo each other, or opposites kill each other technically. So if I start with 5 and I add 2 to it and then I subtract 2 from it, bleh. So if I start with 5 and I add 2 to it and then I subtract 2 from it, then chop chop, I'm left with 5. So if I start with 5 and I multiply it by 2 and then divide it by 2, again chop chop, and we're left with just 5. So a square root and a square are opposites, so they also kill each other, and that leaves us with 5. The next thing we need to talk about are perfect square numbers. So if you take 0 and you times it by itself, or you square it, you get 0. If I take 1 and I square it, I get 1. Oh, if I take -1, I square it, and I get 1. Whoops, I should have left some space. So if I take positive or -2 and square it, I get 4. 3 square it, 9, etc. So the ones that I've written here are the most used ones as far as numbers go. Now, an x times an x is an x squared. So if I take the square root of x squared, chop chop, I'm left with x. Same here, x squared times x squared is x to the 4th. So if I take the square root of x to the 4th, I get x squared. And the same thing would happen here. So remember that square and square roots are opposites, so are cubes and cube roots, etc. So if I have this sign, it's called a radical. The number in this little bitty corner spot is called the index, and the number or the algebraic expression that's under it is called the radicand. Now, note, if I have the square root of something times something, I can split it apart as the square root of the first something times the square root of the second something. Same idea here with division. So if I have the square root of a fraction, I can split it into the square root of the numerator divided by the square root of the denominator. So, let's get started. The square root of 49. Well, let's look in our list. Where's the perfect square 49? Aha, right here. 7 times 7 gave us 49. So the answer here is 49. So what times itself twice gave us 64? Well, that would be 8. And 169, that would be 13. Ooh, we have to split this one into the square root of 1 over the square root of 36. So that would give us 1 over 6. Now, we could do the same thing here. We could take the square root of 100 over the square root of 25, which gives us 10 over 5, which gives us 2. Now, I just want to make a statement with this one. 100 divided by 25 gives us the square root of 4, and the square root of 4 is still going to give us, whoops, I ran out of space. Ran out of video. So the square root of 100 divided by 25 is the square root of 4, and the square root of 4 is equal to 2. Notice, once I get to that point, there's no square root sign anymore. Now, the opposite of the square root of 4 is the opposite of 2. Notice this is on the outside. But on number G, It's on the inside, and that gives us a problem. Because if we go to the number 4, positive 2 squared is positive 4. Negative 2 squared is positive 4. Nowhere in the list of perfect square numbers do we have a negative number. So this one does not exist. Or you can also say it's undefined. Now, number H. I know it's a letter, but I like to call it a number. So, let me move this up here. Notice there's squiggly equals. It isn't exactly just straight line equals. So we take second and x squared, because you see the square root sign right here. And then we put 43, and we close up the parentheses, and we hit enter. So it is approximately 6.557, and it just depends on where they say to round it. Remember, one decimal place is tenths, hundredths, thousandths. Now with number next, it's probably going to say exact answer. Alright, the way we're going to do this one is, I know that it's divisible by 25, because obviously 25 and then the 0. So 25 times 10, 10 is 2 times 5. Well, that doesn't clean up any at all. And then we've got x squared, which is x times x, and y to the 5, which is y times y times y times y times y. And they need to be in pairs of 2. So there's one pair of 2. Here's 2 pairs of 2, but then there's a leftover. Just like with my 25, that would be 5 times 5. There's a pair, but here's a leftover. So when they ask for the exact, your pairs come outside of the parentheses, or not the parentheses, the radical. But since there's some leftovers, you have to put your radical back. Anything that isn't paired up, you put a box around, and you put it back into your radical. So an exact answer looks like this. It isn't pretty, but it's still what you got to do. Now, what is an application for square roots? Right here. It's called the Pythagorean Theorem. When we have a right triangle means it has a 90-degree angle. So, just in case you're wondering, there is no such thing as a left triangle. There's a right triangle, there's obtuse, there's acute. But there is no left triangle, by the way. So, remember the Pythagorean theorem is a squared plus b squared equals c squared. C is always, 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 and forever your hypotenuse. A and B are just legs. And remember, legs touch the 90-degree angle. And I'm just going to call this leg A, and this one leg B. So when I do this, I get 10 squared plus 17 squared equals c squared. 10 squared is 100. And in our list, we do not have 17, so I'm going to use Good Buddy Calculator. And 17 squared is 289 equals c squared. 100 plus 289 gives us 389 equals c squared. The opposite of squaring is to take the square root. So chop chop, c equals, and I'm going to take the square root of 389, and as you can see, this is an ugly answer. So 19, and I'm going to just stop it at 0.7. So 19.7, and it would be meters. Now, in every other case, when we do a variable squared equals something, then we have to take both the positive and the negative, because like up here, when you do your perfect square numbers, they started out positive and some started out negative, but both of them ended up a positive answer once you squared them. But now length cannot be negative, so we have to throw away that part of it. Now, when we're looking for the hypotenuse, what did we do with the square of our legs? We added. This next problem is an issue. This one's a leg. We have our hypotenuse. So we're going to call that one B. So we take a squared, which we don't know what it is, plus 12 squared equals 13 squared. So a squared plus 144 equals 169. Uh-oh. Now we got to get this to the other side, and that's not a big deal because we've already taken care of chapter 13 or chapter 3. So we got to take this to the other side. The opposite of adding it is to minus it. So a squared equals 25. And the opposite of squaring is to square root, so chop chop. A equals both positive and negative 5, but length is positive, so we throw that negative part away. Now the last part of what you could see in this is, can these be the sides of a right triangle? Well, you always put it in this order, A, B, C. So you take 8 squared plus 15 squared equals 17 squared. 8 squared is 64, and 15 squared was in our list. It was 225, and we just did right here 17 squared, so equals 289. 5 plus 4 is 9. 2 plus 6 is 8. And 2 plus nothing is 289. So in this case, yep, that one is equal to the sides of a right triangle. So now we do 24 squared plus 30 squared, and is that equal to 40 squared? So 24 squared is 576, and 30 squared is 900. Then 40 squared is 1600, and then you take 900 plus 576, and that gives us 1476, which is not equal to 1600. So you would say, nope, that one does not work. Ooh, what about number C? And this happens to be number last as well. Well, guess what? We don't treat this any different. Okay? Square root of 2 squared plus the square root of 7 squared equals 3 squared. Square root squared, chop chop, chop chop. And 2 plus 7 equals 9, and yes, 9 equals 9. This one checks out, so yep, that one works. Have fun with the homework.